Welcome to Siddhartha Institute of Science and Technology, Puttur. Very good morning to all of you. Myself, Laxman Sudheer. Today, I would like to tell about Wheatstone Bridge. So, before we are going to the Wheatstone Bridge, what is meant by bridge and what are the different types of bridges and what are the measurements we are calculating by using the bridges. So, let us see first what is the bridge. So, bridge is nothing but it consisting of a four arms. So, that four arms are maybe resistance or capacitance or any inductance or any combination of parallel or series. So by using those bridges, we can calculate the resistance value, capacitance value, inductance value, and frequency value. So in that, bridges are divided into two types. One is DC bridge and second one is AC bridges. So now we can see what is the bridge. So in that, bridge is nothing but it is a precise measurement of resistance and reactive components. So mainly it is used for precise measurements. That means exact measurements of the resistance or reactive components or impedances or temperature, pressure, strain and any other physical quantities. And the bridges are also used to rectify the AC signals. So that AC signals we have to rectify and filters and oscillators. So mainly the bridges are not only used for the measurement of resistance but also used for the various components, either capacitance or inductance. We are already discussed in the first point. The bridges are used for measurement of resistance, capacitance, inductance, frequency. And the bridges are divided into two types. In that also balanced bridge and unbalanced bridge. So the balanced bridge means the opposite arms are always equal. Unbalanced bridge means the opposite arms are always not equal. So if the bridge opposite arms are equal, then the bridge is said to be balanced bridge. If the opposite arms are not equal, then the bridge is said to be unbalanced bridge. So now we can see the first one, Wheatstone bridge. So we are already discussed what is meant by bridge. The bridge is nothing but it consisting of four arms. So mainly the Wheatstone bridge is used for measurement of purely resistance. So that's why each and every arm consisting of the resistance. So this is the first arm and the second arm and third arm and fourth arm. So four arms we are taking the purely resistances. In that the two arms are standard resistances. The remaining two arms and the one arm is variable resistance. So variable means the values will be changes. The component names we are taking as the A, B, C, D. So in that we are connecting the opposite two arms is a voltage source and the remaining two arms we are connecting with to the galvanometer. So this is the construction part of the Wheatstone bridge. So now we can see. So what is the operation of that Wheatstone bridge? So how it will be operation means the switch is closed condition and the switch is open condition. So now I can see. Suppose if the switch is closed condition, so what it will happen? If the switch is open, what it will be happen? So now we can see the first condition, the switch is closed. So when the switch is closed, current flows. So that means whatever the current passing, that current flows. So current flows and divides into the two arms at point A. So at this terminal point, the current of that I is divided into two arms. That is I1 and I2. So initially, the current is capital I. So when the current enter into this terminal point, the current is divided into two. One is I1 and another one is I2. So the bridge is balanced. So what is that? Your bridge is balanced. So what is meant by balanced? And there is no current through the galvanometer. So when the bridge is balanced means when there is no current passing through the galvanometer. If the current doesn't pass through the galvanometer, then the bridge is said to be balanced. So what is the condition? So when the current doesn't pass through the galvanometer, then potential difference at C terminal point and D terminal point is always equal. So that means the current does not passes through the galvanometer. It will be equipotential. That is C terminal point and D terminal point. So what is the balance equation? So that means what is the dq potential? The potential across the galvanometer is 0. So at that the balancing equation is at this terminal point A and C. What is the current passing? I1 and the resistance is R1. According to the Ohm's law, what is the Ohm's law? V is equal to IR. So at A terminal point and C terminal point, current I1 is passing and the resistance is R1. So therefore, I1 into R1. And same similarly at A terminal point and D terminal point, current is passing I2 and resistance is R2. According to the Ohm's law, V is equal to I into R. I2 into R2. So what is the equipotential at the C terminal point is equal to D terminal point. So whatever the current passing at the C terminal point or voltage at the C terminal point is always equal to the D terminal point. So voltage at A to C terminal point is equal to voltage at A to D terminal point. So therefore, I1 into R1 is equal to I2 into R2. Next, for the galvanometer current to be 0, so what is that? Galvanometer current is 0. Then, whatever the current passing through the resistance R1 is equal to the passing through the resistance R3. Therefore, I1 is equal to I3. So, why we are taking I1 is equal to I3? Because at galvanometer, current is equal to 0. So, therefore, I1 is equal to I3 and same similarly at D terminal point I2 is equal to I4. So I1 is equal to I3, I2 to I4 that is equal to. So now this terminal point 2 at B terminal point the current is same current. I1 current is equal to I3. That means there you can take I1 current or I3 current. So whatever the currents are passing through the resistance R1 and passing through the resistance R3, both are equal. So I1 is equal to I3. Therefore, at this terminal point A to B terminal point, the total current is I. So I3 is equal to that the total voltage is V divided by the two resistors are connected in series positions. Therefore, V divided by R1 plus R3. The same similarly at D terminal point, this I2 is also equal to I4. So therefore, at A to B terminal point is also the current, the voltage is capital V. So V divided by R2 plus R4. Why we are taking the R2 and R4 will be summing? Because both are connected in series position. Therefore, I1 is equal to I3. It is equal to V divided by R1 plus R3 and I2 is equal to I4 and V divided by R2 plus R4. So this is the currents calculation when there is no current passing through the galvanometer. Next. So now you can substitute the previous currents of I1, I2 in, so that we are already know that I1 into R1 is equal to I2 into R2. So that I1 current is we are already calculated and I2 current is already we calculated. So therefore after substituting the values, then after simplifying this equation, then we can get R4 is equal to R2 R3 by R1. So this is the equation for the bridges to be balanced. So the bridge is balanced condition, the resistance R1, R4 is equal to R2, R3. So when you can clearly observe that the opposite arms of the resistances are always equal. R1, R4 is equal to R2, R3. So in practice, at least one of the resistance is made adjustable. So when you can observe the circuit diagram, one arm resistance is variable resistance and the remaining three are standardable resistance. So why we are considering one is standard, remaining three are, one is variable, The remaining three are standard. Means for the balancing condition. So in practical, at least one of the resistance is made adjustable to permit balancing. So when the bridge is balanced condition, the unknown resistance will be determined as Rx is equal to R3 by R1. This is the balanced Wheatstone bridge. So next coming to that, in that balanced Wheatstone bridge, we can calculate the sensitivity also. So when we can calculate the sensitivity means unbalanced condition. So what is the balanced and unbalanced? Balanced means the current does not passing through the galvanometer. So now the current passing through the galvanometer. Suppose if the current is passing through the galvanometer, then we need to calculate how much of current passing through the galvanometer. So that is calculated by using different types of the theorems in the network theory. So when the bridge is in unbalanced condition, current flows through the galvanometer. So when the current passing through the galvanometer, it causes a deflection of the pointer. Causing deflection means changes. So once the current is passing means definitely the pointer also will be changes. So when the pointer will be changes, when the current passing through the galvanometer. When the current passing through the galvanometer means that condition is unbalanced condition. So this amount of deflection is a function of the sensitivity of the galvanometer. This amount of deflection we can function of the sensitivity of the galvanometer. How we can calculate the sensitivity means the sensitivity is equal to deflection by current. This is the procedure of calculating the sensitivity of the corresponding bridge. So this is the unbalanced condition. So when we can observe in the previous one and the present one, in the previous the galvanometer is there, but the current passing is zero. But here the galvanometer is not there, but the current passing through the galvanometer. That means we have to calculate how much of current passing. So they determine the amount of deflection that would result for a particular degree of unbalanced condition. So determining the current through the galvanometer with the help of network theorems. So for this circuit diagram, we are taking the Thevenin's equivalent circuit. So that means Thevenin's means we have to converting this bridge into Thevenin's equivalent circuit. How we can converting into Thevenin's equivalent means just disconnecting the galvanometer from the bridge circuit. So for the conversion of Thevenin's equivalent circuit, first we can disconnect the galvanometer between the points of the terminals. So we can find the Thevenin's equivalent voltage, and also to determine the open circuit voltage. So A and B will be open circuit. So just we can apply the voltage divider. What is the voltage divider rule? Wherever you are calculating the voltage, that particular voltage into resistance divided by total resistances. So at A terminal point is V, the total voltage is V. So V into R3 by R1 plus R3 because these two are connected in series position. Same similarly at B terminal point R4 divided by R2 plus R4. So next, the difference between the A and B terminal voltage is VAB is equal to VA minus VB is the Thevenin's voltage. So after substituting the values, we can get this Thevenin's equivalent voltage. So once calculate the Thevenin's voltage equation, then we can calculate the resistance value. How we can calculate the resistance means Thevenin's equivalent resistance can be determined by replacing the voltage source within its internal impedances. So otherwise short circuited and calculate the resistance value. So this is the procedure of calculating the Thevenin's resistance. So after the Thevenin's resistances, then we can calculate the total current. So that is V Thevenin by R Thevenin plus R. So this is the procedure of calculating the unbalanced Wheatstone bridge. So mainly the Wheatstone bridge is used for calculating the resistance value that one is balanced Wheatstone bridge, another one is unbalanced Wheatstone bridge. So balanced means when there is no current passing through the galvanometer, then it is a balanced bridge. Unbalanced means when there is a current passing through the galvanometer, then it is a unbalanced Wheatstone bridge. So when the bridge is balanced means the balancing equation is opposite terms are always equal. This is the Wheatstone bridge. Thank you.